Okay, so we're back to finish up the scientific notation. So on page 6, number 3 is 0.000472. So if you remember your decimal point or your decimal place values, this is tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So 472 millionths is what this is. So again, think about if I take my piece of paper and I split it up into a million pieces, think how tiny they'd be. I'm going to give you 472 of those out of a million. Okay, not very much. So this is standard notation. This is just a plain old number. It's a little number, but just a plain old number. Again, to make it scientific notation, I want to have some number times 10 to some power. So again, I need to move that decimal point, or you could think about this time shoving my number this way so it goes there. So then that decimal point needs to go not here. Okay, this really typical mistake is to put it here. But if I put the decimal point here, I still have 0.472. That's not between 1 and 10. So I have to move it to right here. So I'm going to have 4.72. How many places did I move it? 1, 2, 3, 4. Okay. Now, 4, forget about the 0.72 for a minute. 4 times 10 to the 4th would be 4 times 10,000. That would be 40,000. Is that what I have? No. That would give me a big number. Because I started out with a little tiny number here, anything less than 1, my exponent has to be a negative. 10 to the negative 4th is 1/10,000th. This would take 4 and make 1/10,000th of that. It would be really small. Okay, number 4. 0.019, 19 thousandths. So again, I'm going to move my decimal point over until there's one non-zero digit in front of it. So 1.9 is between 1 and 10. I moved it 2 places. Because I started out with a smaller number than 1, I have to have a negative exponent. All right, number 5 through 8 are written in scientific notation, and we need to write it in standard notation. And again, this is where sometimes people have memorized or tried to be taught to memorize when I go left, when I go right. Okay, again, I don't want you to just memorize it. So number 5 says 4.73 times 10 to the 6th. This 10 to the 6th tells me that I'm going to end up with a big number. Okay? So if I'm going to end up with a big number, it's 4 times a million, then I want my decimal point to go this way to give me a big number. If I moved it this way, it would be 0.0000, right? So that's how I know which way to move it. So it started here. I'm going to move it 6 places. Well, 1, 2, I'm out of numbers. 3, 4, 5, 6, it's going to be right here. These 4 are going to get filled in with zeros. So I go back and do my decimal or my commas. It's 4,730,000. That makes sense because we said 10 to the 6th is a million. So 4 times a million is 4 million. And then the 0.73 gives us the part of a million. Okay, so you go ahead and try 6, 7, and 8 while I am writing them up on the board. Then you can check your answers up here. Oops, I'm not going to. Okay, so number 6, 9 was multiplied by 1,000, right? So it makes sense that I got a bigger number, 9,200. Here I have a negative exponent. That tells me that I'm going to end up with a small number. It's 1 times 1/10,000th, 1/10,000th of one thing. So I move it this way 4 places. So it starts out here. I move it 1, 2, 3, 4. Again, fill in with zeros. Notice these 3 zeros are these 3. I just put a 0 in front of the decimal because it makes it a little bit easier to read. And then same idea here. Start out with 8 here. Move it over 2 places. I'm going to the left because that gives me a smaller number. Okay, so hopefully that gave you a good amount of practice on the exponent rules and then scientific notation, which you can see is related to the exponents and how they work. All right, so I'm going to stop this video now, and then in a day or so, probably tomorrow, I will make the videos for the rest of the packet, which talk about radicals or roots, square roots, cube roots. So start thinking about those a little bit. We're going to be getting into some things that maybe you haven't seen before with those. But you could start doing the homework for the exponent part in the meantime. All right, I will see you guys later.